For this video, we're still looking for oblique asymptotes. So for this problem, h of x equals 2x cubed minus 5x minus 10 divided by the quantity x squared minus 4. The power of the numerator is 1 more than the power of the denominator. We have an x cubed divided by an x squared. So it's possible that we actually do have an oblique asymptote here. But we have to make sure we don't have any common factors. So if I look at my numerator, I actually don't know how to factor it. But if I look at my denominator, I do. And I really only care if I have a common factor. So if I look at my denominator, I know that that's x minus 2 times x plus 2. So it only matters if this is one of these two is actually a factor of the numerator, and I can find that out pretty quickly. If x minus 2 is a factor in the numerator, then I know x equals 2 is a 0. If x plus 2 is a factor, then x equals negative 2 is a 0. So I should be able to plug these two numbers into my numerator and see if I get 0 out at the end. So 2 times 2 cubed is 16 minus 10, that's not 0. If I evaluate at negative 2, that's a negative 16 plus 10 minus 10, and that's not 0. So neither one of these factors is actually a factor of the numerator. So I can actually just go straight to the long division. I have x squared minus 4, and that is dividing into 2x cubed minus 5x minus 10. So I know x squared times an x is my x cubed, but I also need a 2, so I'll put a 2x right there, and then I'll multiply down. So 2x cubed minus 8x. Then I need to subtract. This cancels out. I'm left with a 3x minus 10, and I appear to be done. X squared does not go into the 3x minus 10, so I know that h of x could also be written like this: my whole number piece plus my remainder, 3x minus 10, over what I'm dividing by, which is x squared minus 4. Looking at this now, remember that this first piece is your asymptote. So my oblique asymptote will be y equals 2x. This piece, when I plug in an x value, would tell me the distance from my function to the asymptote at that x value. Now it's important to note that if you have a slant asymptote and oblique asymptote, the equation has to be linear because it's a line, it's a straight line. So I could have had y equals 2x if my division had worked out, like if this had been an x squared over here, something, and I brought something down, then I could have had maybe a y equals 2x plus 1, something along those lines. But you can't have an x squared. That's why it's important that this is just 1 higher than this. The power in the numerator is 1 more than the denominator. But y equals 2x for this problem is my asymptote. If I look at this problem, I have the highest power of x is in x to the 4th. My numerator, x to the 3rd, and my denominator. That's 1 higher in the numerator, so it's a possibility. I look to see if I have any common factors, and I have absolutely no idea how to factor that easily. No idea how to factor this, but chances are slim. If you look at this x cubed minus 7, 7's prime. So I would have to be able to plug in a 1 or a 7 and get a 0, because I'd have to have an x minus 7 or an x minus 1 in the mix of all of this. If I plug in a 1, it's 5 minus 2 plus 4 minus 10. That is not 0. If I plug in a 7 or a negative 7, chances are really slim, so I'm willing to risk it. Now, all that will happen to you if you divide by something here, and it is a common factor, is that you should end up with a 0 remainder. If you get a 0 remainder, you don't have an asymptote there. So I'm going to go straight to the division. So we have 5x to the 4th minus 2x cubed plus 4x squared minus 10 divided by x cubed minus 7. I look at my first terms. I need to multiply this 5x cubed by a 5x to the 1st to actually get the 5x to the 4th. Then I multiply it. So I have 5x to the 4th minus 35x. Subtract, so I'll change those signs, and I am left with a negative 2x cubed. This canceled out. These cannot combine, so you bring them both down, plus a 35x. I look again, x cubed times what would give me a negative 2x cubed, and that's a negative 2. I multiply down, so negative 2x cubed plus 14. Going to subtract, so change the signs. That cancels out. These two do not combine, so 35x minus 14. And then I can't divide anymore. And you'll notice for this one, I again have a linear function. This one happens to have both the slope and the intercept showing. So I know that j of x is equal to 5x minus 2 plus my remainder, 35x minus 14, divided by x cubed minus 7. This piece is my asymptote, and this is the distance from the asymptote to the function. So my asymptote will be y equals 5x minus 2. Here's one more problem I wanted to talk about, and that is this one. If you'd been asked to actually find an oblique asymptote, it should give you pause. The power in the the power in the denominator is greater than the power in the numerator. You can stop there, because even if we had common factors and we canceled out, you're always going to have more x's in the denominator than in the numerator. You'd be canceling out the same number of x's, or the same number of factors. So there's no reason to go further in this problem. We know that there are no oblique asymptotes. But it is important to note that this one does actually have a horizontal asymptote. There are more x's in the denominator, like a higher power of x in the denominator than the numerator. So if I look at dominant terms for this problem, the limit as x approaches, and we can look at infinity and negative infinity, but again, polynomial over polynomial, you're going to get the same answer. We have a 3x cubed over an x to the 4th. If we reduce this, it's the same thing as asking the limit as x approaches infinity, a 3 over x. We evaluate 3 divided by something huge, goes to 0, and we have a horizontal asymptote at y equals 0. So no oblique, but yes to horizontal.